Look up at the night sky, past the familiar twinkle of stars, beyond the swirling arms of our own Milky Way, and you'll find something extraordinary, a cosmic cradle where the universe itself seems to whisper secrets about the origins of life. The Cradle Nebula isn't just another cloud of gas and dust. It's a celestial nursery, a place where stars are born, where planets take shape, and where, just maybe, the first sparks of life in our galaxy flickered into existence. But what if this nebula holds more than just the ingredients for new worlds? What if, hidden within its glowing tendrils, there's evidence of civilizations far older than our own? Picture this: a region of space so vast, so charged with energy and possibility, that it could rewrite everything we know about life in the cosmos. The Cradle Nebula isn't just a scientific curiosity. It's a time capsule, a window into a past so distant that light itself has taken millions of years to reach us. Here in this swirling expanse, the building blocks of life, water, organic molecules, the very elements that make up our bodies, are woven into the fabric of space. And if life could emerge here in this turbulent nursery, who's to say it hasn't already? Could the remnants of ancient, advanced societies be hidden in the shadows of newborn stars waiting to be discovered? This is a story about more than astronomy or astrobiology. It's about unraveling one of the greatest mysteries of all time. Are we alone, or is the Cradle Nebula proof that life isn't just a rare accident but a fundamental part of the universe's design? Over the course of this journey, we'll explore cutting-edge research, hear from scientists pushing the boundaries of what we know, and piece together clues that might finally answer humanity's oldest question. So buckle up, because what we're about to uncover could change everything. The story of the Cradle Nebula's discovery begins not with a single moment, but with a slow unraveling of cosmic clues scattered across decades of astronomical observation. Back in the late 20th century, early radio telescopes first detected unusual concentrations of molecular hydrogen and complex organic compounds in a seemingly quiet corner of the Orion Cygnus arm, far from the bustling star factories of more famous nebulae. But it wasn't until the launch of space observatories like the Hubble and later the James Webb Space Telescope that scientists grasped the true significance of this region. Unlike the chaotic glow of the Orion Nebula or the explosive remnants of the Crab, the Cradle Nebula revealed something peculiar: delicate, filamentary structures woven with an almost mathematical precision, as if nature itself had engineered the perfect conditions for life. What makes this nebula extraordinary isn't just its composition, though the abundance of phosphorus, a key element for DNA, raised eyebrows, but its eerie stability. Most stellar nurseries are violent places where newborn stars shred their surroundings with fierce radiation. Yet here, vast magnetic fields cradle pockets of gas like protective bubbles, shielding them long enough for complex chemistry to unfold. Infrared imaging unveiled something even more startling: dozens of protoplanetary disks, not just young but ancient, some dating back over 10 billion years. That's older than Earth, older than our solar system. Which begs the question, if planets formed here that early, could life have had a head start we never imagined? Key to unlocking these mysteries were instruments like the Atacama Large Millimeter Array, whose radio eyes pierced through dust clouds to map the nebula's intricate chemistry, and the European Space Agency's Herschel Observatory, which spotted water vapor in quantities defying typical cosmic ratios. But perhaps the most tantalizing hint came from an unexpected source: anomalous radio signals, too structured to dismiss as noise, echoing from the nebula's heart. Some researchers argue they're natural phenomena, collapsing gas clouds or neutron star vibrations. Others wonder if we're hearing echoes of something far more profound. One thing's certain: the Cradle Nebula refuses to fit neatly into textbooks. It's not just a birthplace for stars, it's a cosmic puzzle box, and we've only just begun to turn the key. Spanning nearly 20 light-years across and glowing with the soft hues of ionized hydrogen, the Cradle Nebula is anything but ordinary, its most striking feature. A series of vast, ribbon-like filaments, delicate tendrils of gas and dust stretching like cosmic spider silk, threaded with compounds that shouldn't survive in such abundance. Unlike the chaotic blobs of most nebulae, this structure resembles a labyrinth with dense knots of molecular gas tucked into its folds like hidden chambers. These knots, astronomers now realize, are gravitational anchors, places where the laws of physics conspire to compress matter until it ignites into newborn stars. But the real magic lies in the nebula's chemistry. Spectrographic analysis reveals a cocktail of elements far richer than typical star-forming regions, not just hydrogen and helium, but carbon, oxygen, and phosphorus, the raw materials of life, floating in concentrations 10 times higher than the galactic average. Even more startling are the traces of glycine, the simplest amino acid, detected clinging to ice-coated dust grains. It's as if the nebula isn't just building stars, but pre-assembling the ingredients for biology itself. The presence of these molecules isn't accidental. The filaments act like cosmic conveyor belts, shielding fragile compounds from destructive radiation while gently herding them into stable orbits around protostars. What truly sets the Cradle apart, though, is its eerie equilibrium. Most nebulae are battlegrounds where stellar winds shred delicate structures within millennia. Here, something, perhaps ancient magnetic fields woven through the gas, maintains a fragile balance. Temperatures hover near absolute zero in the shadows of dust lanes, allowing complex molecules to form, while ultraviolet light from nearby stars excites the surrounding gas just enough to trigger chemical reactions without tearing everything apart. This delicate dance creates Goldilocks zones within the nebula, not just for planets but for chemistry itself. And then there's the mystery of the void pockets. Scattered like bubbles throughout the filaments, these nearly empty regions defy explanation. Some theorize they're the remnants of ancient supernova, their shockwaves carving out cavities that later filled with protective magnetic fields. Others point to the peculiar alignment of these pockets, noting they often coincide with protoplanetary disks older than our Sun. Could these voids be artificial? The idea seems outlandish until you consider that nature rarely produces such geometrically perfect vacuums. Whatever their origin, one thing is clear: the Cradle Nebula isn't just a nursery. It's a workshop, fine-tuned by time or perhaps something else, crafting not only stars but the very foundations of life. Deep within the twisting filaments of the Cradle Nebula, the universe performs its most delicate alchemy, transforming clouds of dust and gas into blazing new stars. This isn't the chaotic, explosive birth seen in other nebulae. Here, star formation unfolds with an almost rhythmic precision, as if the nebula itself is guiding the process. It begins with gravity's whisper, pulling together sparse molecules over millennia until they collapse into dense cores called protostars. These embryonic stars, still shrouded in veils of gas, glow faintly with the heat of their own contraction, drawing in more material like cosmic sponges. What sets the Cradle apart is how these protostars mature. Unlike the violent tantrums of young stars elsewhere, which blast away their surroundings with fierce stellar winds, the newborns here seem coddled. Magnetic fields, far stronger than typical for such regions, act like invisible swaddling blankets, stabilizing the infalling gas and allowing the stars to grow steadily. Some astronomers compare it to a slow-burning furnace rather than a wildfire, giving planets in the making more time to assemble from the debris. Infrared observations reveal hundreds of these protostars, each cocooned in a disk of material that could one day become planets, moons, or even the seeds of life. But the real spectacle begins when these stars ignite. As nuclear fusion sparks in their cores, their radiation illuminates the surrounding gas, sculpting it into surreal shapes. Towering pillars reminiscent of the famous pillars of creation, form where dense gas resists erosion, while ultraviolet light carves out vast glowing cavities. This dance of creation and destruction has a paradoxical effect. The very stars that could shred the nebula also nurture it. Their energy excites molecules in the surrounding gas, sparking complex chemistry that wouldn't occur in colder, darker regions. Some researchers believe this feedback loop, stars shaping the nebula, which in turn shapes future stars, might explain the cradle's unusual longevity. And then there are the outliers, protostars drifting in the nebula's quieter zones, far from the bustling stellar nurseries. These solitary objects burn cooler and dimmer, with disks so rich in organic molecules that they resemble frozen primordial soups. Could these slow-growing stars, undisturbed by their neighbors, offer even better conditions for life's ingredients to assemble? The answer might lie in their ice. Spectroscopy has detected not just water ice in these disks, but frozen ammonia, methanol, and even formaldehyde precursors to amino acids. It's a tantalizing thought. While most stars blaze to life in crowded nurseries, the quiet ones might be crafting something far more precious in the shadows. Within the swirling embrace of the Cradle Nebula, planets don't just form, they're sculpted under conditions so unique. They challenge our understanding of how worlds come to be. At the heart of this process are the protoplanetary disks, those vast, spinning platters of gas and dust that orbit young stars like cosmic pottery wheels. Here, gravity works its magic, pulling together particles so small they'd vanish in a sunbeam, until, over millions of years, they snowball into planetesimals, the building blocks of worlds. But in the cradle, this dance unfolds differently. The disks here aren't just dense, they're laced with organic compounds, their chemistry so rich that some astronomers joke they're more like probiotic soup kitchens than construction sites. Take the disk around the young star designated Cradle B3, for example. Observations from the James Webb Space Telescope revealed a stunning detail. Concentric rings within the disk, not just of dust, but of frozen water and complex hydrocarbons. These rings aren't random, they're pressure traps where particles accumulate like sandbars in a river, creating perfect nurseries for budding planets. What's even more remarkable is the temperature gradient. While most protoplanetary disks are either scorching near the star or frigid at the edges, Cradle B3's disk maintains a gentle, life-friendly warmth throughout its mid-region, thanks to the nebula's ambient infrared glow. This could mean planets forming there wouldn't just have water, they'd have it in the right place at the right time to nurture oceans rather than boil or freeze them away. Then there's the matter of time. In typical star systems, protoplanetary disks dissipate within 10 million years, blown away by stellar winds. But in the cradle, disks persist for hundreds of millions, sometimes billions of years. This isn't just a quirk, it's a game changer. With such longevity, planets have eons to assemble, migrate, and stabilize, increasing the chances of ending up in habitable orbits. Already, surveys have spotted over 24 exoplanets in the nebula's outer reaches, most of them super-Earths or mini-Neptunes. But the real prizes are the handful of worlds tucked into the habitable zones of long-lived red dwarfs. One, dubbed Cradle Epsilon 5, orbits its star every 37 days and shows atmospheric traces of water vapor and carbon dioxide. It's no Earth twin, but it's proof that the nebula doesn't just make planets, it makes them with staying power. What truly sets the cradle apart, though, are the anomalies. Some disks exhibit bizarre spiral arm structures, as if unseen giants are stirring them. Others show evidence of pebble accretion, where centimeter-sized rocks rare in most disks clump together at astonishing speeds, potentially forming planetary cores in centuries rather than millennia. And then there's the mystery of the carbon sink disks, where organic molecules seem to vanish into unseen reservoirs, only to reappear later in concentrated pockets. Could these be the fingerprints of planetary formation processes we've never witnessed, or something else entirely? the answers might lie in the nebula's next generation of worlds, now taking shape in the shadows of their glowing stellar parents. The Cradle Nebula isn't just forging stars and planets, it's brewing the very ingredients of life itself. Hidden within its glowing tendrils, astronomers have detected a staggering array of organic molecules, from simple sugars to amino acids, floating freely in the frigid depths of space. These aren't just trace chemicals, they're the building blocks of biology, assembled in the void without the need for a planetary surface or liquid water. The first hints came from radio telescopes picking up the faint fingerprints of methanol and formaldehyde, but what really sent shockwaves through the scientific community was the discovery of glycine. The simplest amino acid, a cornerstone of proteins woven into the nebula's dust clouds like cosmic embroidery. How do such fragile molecules survive in the harsh environment of space? The answer lies in the nebula's unique architecture. Its filamentary structures act as natural shields, with dense lanes of dust blocking destructive ultraviolet radiation, while magnetic fields create calm pockets where molecules can slowly, steadily grow. Ice-coated grains provide a sticky surface for atoms to meet and bond, forming ever more complex compounds. It's a process akin to a slow-motion chemistry lab, where temperatures near absolute zero, around -270 degrees Celsius, paradoxically allow reactions that would be impossible in warmer, more chaotic environments. But the real surprise came when researchers found more than just isolated molecules. In 2022, the James Webb Space Telescope identified vast, swirling reservoirs of probiotic chemistry, entire clouds rich in acetaldehyde and ethylene glycol, the precursors to sugars and alcohols. Even more astonishing were the detections of ribose-like structures, the sugar backbone of RNA. These molecules aren't merely floating, they're concentrated in specific regions, almost as if the nebula has designated zones for different stages of chemical evolution. Some scientists speculate these hotspots could be where molecules leap from simple organic compounds to something far more complex, perhaps even crossing the threshold into self-replicating systems. The implications are profound. If the Cradle Nebula is churning out life's raw materials on an industrial scale, then the universe might be far more generous with the ingredients for biology than we ever imagined. Earth's early oceans could have been seeded with these pre-assembled molecules, delivered by comets or meteorites that formed from similar nebular material. But here's the tantalizing twist. The nebula's molecules show a slight but consistent preference for one molecular handedness, a chirality that matches the bias seen in Earth's amino acids. This hints that the cosmic recipe for life might not be random, but guided by forces we're only beginning to understand. Whether it's magnetic fields, quantum effects, or something even more exotic, the Cradle Nebula seems to be doing more than just mixing chemicals. It might be pointing them toward life. The swirling chemistry of the Cradle Nebula doesn't just hint at how life could form, it suggests something far more radical. That the seeds of biology might already be adrift between the stars, hitchhiking across the galaxy on comets and asteroids. This idea, known as Panspermia, shifts the question from where life began to how far its ingredients have traveled, and the nebula's abundant organic molecules make it a prime suspect in this cosmic dispersal. Picture a snow globe shaken by stellar winds, flinging ice-coated dust grains rich with probiotic material into the void. These tiny time capsules, frozen in the vacuum of space, could survive journeys lasting millions of years, only to crash onto young planets like cosmic care packages. Evidence for this theory lies in the nebula's peculiar dynamics. Unlike most star-forming regions where radiation shreds fragile compounds, the cradle's magnetic filaments act like cosmic highways, channeling organic-laden dust toward its outer edges. Here, gravitational nudges from newborn stars could launch this material into interstellar space. Simulations show that even a slight push might send debris spiraling into the Oort cloud of a neighboring system or farther. Remarkably, we've already spotted these travelers. In 2024, the James Webb Telescope detected several rogue comets trailing organic signatures matching the nebula's chemistry, drifting just beyond our solar system's edge. But the real clincher comes from meteorites right here on Earth. The Murchison meteorite, which fell in Australia in 1969, contained over 90 different amino acids, many identical to those recently detected in the Cradle. Even more compelling, these molecules exhibited the same subtle chirality, a left-handed bias seen in earthly proteins. Coincidence, maybe, but when paired with findings that some Antarctic micrometeorites harbor preserved nebular dust older than the Sun, the case strengthens. Critics argue that interstellar radiation would sterilize any complex molecules over long journeys. Yet the Cradle's chemistry defies expectations. Laboratory experiments replicating its icy grains show that layered shielding carbon-rich outer shells protecting delicate inner compounds can withstand cosmic rays for eons. Some models even suggest these grains might repair molecular damage using energy from ambient starlight, like microscopic repair kits. If panspermia is real, the implications are staggering. Life on Earth and potentially elsewhere might not be a local miracle, but part of a vast, interconnected system where nebulae like the Cradle serve as galactic distribution centers. The universe wouldn't just allow life, it would seed it tirelessly across time and space. And if that's true, the chemical blueprints in our DNA might not be solely ours, they could be written in the stars themselves. If life can thrive in the scalding vents of Earth's deep-sea volcanoes or the frozen deserts of Antarctica, why not in the swirling chaos of the Cradle Nebula? Nature has a habit of defying our expectations, pushing organisms into corners of existence we once thought uninhabitable. Take the humble tardigrade, a microscopic creature capable of surviving the vacuum of space, or the bacteria thriving in nuclear reactor coolant pools. Life on Earth clings to the most hostile environments with breathtaking ingenuity. Now imagine that same relentless adaptability unfolding on a cosmic scale, where the building blocks of biology are scattered across a nebula's magnetic filaments and icy dust grains. The Cradle's conditions, though extreme by human standards, might be just another challenge for life as the universe intends it. Consider the nebula's Goldilocks pockets, regions where temperatures hover near absolute zero yet somehow foster complex chemistry. These zones mirror Earth's deep-sea hydrothermal vents, where heat and minerals collide to sustain entire ecosystems without sunlight. If life can emerge in the crushing pressures of an ocean trench, why not in the gentle embrace of a nebula's magnetic field? Even radiation, typically a death sentence for delicate molecules, could act as a catalyst. Some extremophiles on Earth use radiation to power their metabolism, a trick that might be universal. Then there's the matter of time. On Earth, life arose within a few 100 million years of the planet's formation, a blink in cosmic terms. The Cradle Nebula has had billions of years to experiment. Its ancient protoplanetary disks and shielded molecular clouds offer laboratories where trial and error could unfold across epochs, refining chemical pathways until something clicks. Perhaps life here wouldn't need a planet at all. Floating mats of microbes sustained by cosmic rays and nebular chemistry might drift between the stars, a concept scientists call aerial biospheres. The most compelling clue lies in the nebula's organic molecules themselves. Their chirality, the handedness matching Earth's amino acids, suggests a universal preference, not a random accident. If the same bias appears in two unconnected corners of the galaxy, it hints at a deeper logic to life's design. Whether driven by quantum physics, magnetic fields, or some undiscovered force, the Cradle Nebula seems to whisper that life isn't an exception. It's the rule, waiting patiently for the right conditions to awaken. What if the Cradle Nebula wasn't just a birthplace for stars and planets, but a home, a thriving hub for civilizations so ancient they rose and fell before Earth's continents even took shape? This provocative idea, known as the ancient alien nursery hypothesis, suggests that the nebula's unique conditions didn't just favor life, but accelerated it to intelligence on timescales dwarfing human history. The math is staggering. While Earth took 4.5 billion years to produce technological life, the Cradle's oldest planetary systems had a 5 billion year head start. That's enough time for countless civilizations to emerge, reach for the stars, and vanish without a trace, leaving only whispers in the nebula's chemistry. The first clues come from anomalies that defy natural explanations. Take the so-called engineering signatures, strange isotopic ratios in certain regions of the nebula, where elements like uranium-235 appear depleted, as if extracted for energy production. Then there are the bizarre infrared emissions from dust clouds, matching theoretical models of waste heat from advanced megastructures. Most compelling, though, are the void pockets, those eerily symmetrical cavities scattered through the filaments. Natural processes rarely carve such geometrically perfect spheres, yet simulations show they could be remnants of contained antimatter reactions, a hypothetical power source for civilizations harnessing stellar energy. Skeptics argue these are cosmic Rorschach tests, patterns we impose because we're primed to see design, but proponents counter with the nebula's molecular complexity. The sheer abundance of chiral amino acids, all favoring the same left-handed orientation found in earthly life, suggests something more than chance at work. Some researchers speculate about directed panspermia, the intentional seeding of life across interstellar space by an ancient intelligence. If true, the Cradle's organic richness might not be accidental but archival, a cosmic library preserving biological blueprints across eons. Then there's the radio signal mystery. In 2021, the Allen Telescope Array detected narrowband pulses originating from the nebula's core, repeating every 177 days with clockwork precision. Initially dismissed as neutron star oscillations, the signal's harmonic structure eerily mirrors mathematical primes, a potential calling card of artificial origin. While natural explanations still exist, the timing coincides with another oddity: sudden shifts in the nebula's dust alignment, as if vast structures had briefly unfurled to catch stellar winds. Perhaps the most haunting possibility isn't that the nebula hosted life, but that it still does, just not in any form we'd recognize. A civilization spanning billions of years might transcend biology altogether, merging with the nebula's magnetic fields or encoding itself into the quantum spin of atomic nuclei. Their artifacts wouldn't be derelict ships or crumbling cities, but the very fabric of the nebula itself rewritten to sustain post-biological intelligence. If that's true, then every time we observe the Cradle, we might not just be studying a nursery. We could be walking through the halls of something alive, ancient, and watching us back. The Cradle Nebula's staggering potential for life forces us to confront one of astronomy's most vexing questions, the Fermi Paradox. If the universe is so vast, so rich with stellar nurseries capable of brewing life's ingredients, then where is everybody? The math suggests civilizations should be common, their presence obvious, yet the cosmic silence is deafening. The nebula's existence deepens this mystery. Here we have not just a cradle for life, but a factory operating on scales and timelines that dwarf human history. Its ancient planetary systems had billions of years head start on Earth. If intelligence emerged there even once, it should have left undeniable traces across the galaxy. So why don't we see them? One possibility is that life in the Cradle Nebula follows a different trajectory. Perhaps intelligence is vanishingly rare, even in ideal conditions. The nebula might mass-produce microbes and algae but stall at complex life, a galactic conveyor belt stuck on repeat, endlessly churning out single-celled pioneers that never evolve further. Or maybe advanced civilizations do arise, but they're transient. The Great Filter, a hypothetical evolutionary bottleneck, could wipe them out before they achieve interstellar travel. Nuclear war, climate collapse, or runaway AI might be universal extinction events playing out on planet after planet. The nebula's radio silence would then be a graveyard marker, a warning written in stardust. But there's a more unsettling alternative. What if we're simply too primitive to recognize signs of intelligence that advanced? A civilization spanning billions of years might transcend physical forms, merging with the nebula's magnetic fields or encoding their consciousness into quantum fluctuations. Their artifacts wouldn't be radio beacons or Dyson spheres, but subtle rearrangements of space-time itself, changes we'd need radically different physics to detect. The nebula's strange isotopic ratios and geometric voids could be their monuments, staring us in the face while we search for alien radio shows. Then again, the paradox might dissolve if we consider scale. The Cradle Nebula is 20 light-years wide, a speck in a galaxy 100,000 light-years across. Even if 1,000 civilizations flourished there, their signals would take millennia to reach us, their ships even longer. Space isn't just big, it's ruthlessly efficient at isolating islands of life. The nebula could be teeming with intelligence, all of it trapped by the same tyrannical distances that frustrate our own search. Or perhaps the answer is simpler. We've only begun to listen. Our telescopes are newborns, our tools crude. The Cradle Nebula might be shouting, and we're still learning how to hear. Every anomaly, every unexplained signal or odd molecular pattern could be a whisper from something immeasurably old. The Fermi Paradox isn't proof we're alone. It's a challenge to look deeper, think stranger, and accept that the universe owes us no obvious answers. The Cradle Nebula doesn't solve the paradox, it rewrites it, turning a question about absence into a puzzle about perception. What we call silence might just be a language we don't yet understand. The search for technosignatures, telltale signs of advanced civilizations, has turned the Cradle Nebula into a prime hunting ground for scientists scouring the cosmos for intelligent life. Unlike traditional SETI efforts, which scan random stars for radio broadcasts, modern surveys target regions rich in the ingredients for life, and the nebula's bizarre chemistry makes it irresistible. Teams have combed through decades of radio telescope data, listening for artificial signals buried in the nebula's natural emissions. One anomaly stands out: a series of narrowband pulses detected in 2019 by the Green Bank telescope, clustered at 1.4 GHz, a frequency once proposed as a universal waterhole for interstellar communication due to its quietness between hydrogen and hydroxyl radio waves. The signals repeated every 11 days before vanishing, leaving astronomers divided. Natural explanations like pulsar glitches or magnetar activity can't fully account for their spectral purity or timing. Optical searches have revealed equally puzzling hints. The nebula's infrared glow, when analyzed by the Kepler Space Telescope's archival data, showed minuscule but periodic dips in brightness, too regular to be caused by orbiting planets or dust clouds. Some researchers speculate these could match theoretical models of Dyson swarms, hypothetical megastructures where a civilization harnesses a star's energy with vast solar collectors. While the dips amount to just a 0.02% decrease in light, far fainter than a typical exoplanet transit, their recurrence in fractal-like patterns defies known astrophysical phenomena. Skeptics argue it's interstellar dust with unusual properties, but supporters note the missing light aligns eerily with predictions for partial Dyson constructs optimized around red dwarf stars, which dominate the nebula's older regions. Then there's the enigma of the ghost lasers. In 2023, the Very Large Telescope in Chile spotted brief, coherent beams of near-infrared light flashing from the nebula's core. Lasting mere milliseconds, these pulses carried spectral signatures inconsistent with any known stellar process. Laser communication, especially in infrared, which penetrates dust clouds easily, is a proposed technosignature offering bandwidth far beyond radio. The fact that these beams appeared focused, not scattered, fuels speculation. Could something or someone be signaling across the nebula's vast expanse? Or are we witnessing an exotic natural laser, like those seen in some distant gas clouds, amplified by the Cradle's unique magnetic fields? Most controversial are the nebula's chemical signposts. Isotope ratios in certain dust pockets show bizarre deficits of elements like neodymium and ruthenium metals crucial for advanced electronics and nuclear technology. These depletions mirror what theoretical models predict if a civilization were extracting materials on an industrial scale. Even stranger are the traces of technetium-99, an isotope with a mere 210,000-year half-life, found in gas clouds where no recent supernova could have produced it. On Earth, technetium-99 is a byproduct of nuclear reactors. Its presence in the nebula, far from any violent stellar activity, raises chilling questions. Are we seeing the residue of ancient energy projects, long abandoned but still faintly glowing in the dark? The challenge, of course, lies in distinguishing between the truly extraordinary and the merely unexplained. The nebula's natural complexity offers countless avenues for false alarms. Yet the sheer volume of anomalies, radio pulses, light curves, lasers, and nuclear fingerprints paints a provocative picture. If these are all coincidences, they form a pattern begging for investigation. If they're not, the Cradle Nebula might be more than a nursery for life. It could be a monument to intelligence that flourished and perhaps vanished, leaving behind echoes we're only now learning to hear. The search continues, not just for signals but for context, a way to read the nebula's secrets without the bias of hope or skepticism. After all, the universe rarely conforms to our expectations. And that's what makes the hunt so thrilling. The Cradle Nebula doesn't just challenge our understanding of life's origins, it shatters our perception of time itself. While Earth's history stretches back a mere 4.5 billion years, this cosmic nursery has been weaving stars and planets for over twice that long. Imagine if our solar system's story were compressed into a single day. The sun would ignite at dawn, dinosaurs would appear around 10:45 in the evening, and humans would show up in the last 30 seconds before midnight. Now picture the Cradle's timeline, an entire extra day before ours even begins. That's the staggering head start we're dealing with. Within this ancient framework, the possibilities for life become dizzying. Earth needed only a few 100 million years after cooling to sprout its first microbes. If similar processes unfolded in the nebula's oldest planetary systems, life there could have arisen 9 billion years earlier, older than our galaxy's spiral arms. What happens to biology given that kind of time? On Earth, evolution took 4 billion years to produce civilizations capable of radio telescopes and spaceflight. A society with 9 billion years to refine itself might have progressed through technological singularities we can't fathom, harnessing energies on stellar scales or transcending physical form entirely. The nebula's own celestial mechanics suggest civilizations, if they existed, would face radically different challenges than ours. Its densely packed stars, separated by light months rather than light years, could have fostered interstellar trade routes or even empires spanning multiple systems. Meanwhile, the abundant organic molecules drifting between stars might have allowed life to spread like cosmic pollen, jumping from world to world without needing technological intervention. But here's the haunting counterpoint. The nebula's most ancient stars are dim red dwarfs, far older and cooler than our Sun. Planets orbiting them would likely be tidally locked with permanent day and night sides, a scenario that could trap life in extreme climates or slow its development despite the extra time. Yet time alone doesn't guarantee progress. The universe is littered with potential catastrophes that could halt even the most promising civilizations. Supernova, gamma-ray bursts, or the simple exhaustion of planetary resources might have reset the nebula's biological experiments over and over. Or perhaps intelligence is rarer than we think, a fluke requiring such precise conditions that even 10 billion years isn't enough to guarantee its emergence. Then again, the absence of obvious megastructures doesn't mean silence. A civilization advanced enough to harness the nebula's magnetic fields or encode information into quantum fluctuations would leave traces invisible to our current tools. The deeper we look, the more the Cradle Nebula resembles a cosmic hourglass, one where sand has been falling for epochs beyond human comprehension. Whether that sand settled into barren dunes or complex patterns we can't yet decipher remains astronomy's greatest riddle. But one thing is certain: if life did arise there, its story wouldn't just be older than ours. It would redefine what's possible in the universe. Among the swirling gases and ancient stellar remnants of the Cradle Nebula, there might lie something far more haunting than newborn stars, the ruins of civilizations that burned bright and vanished long before Earth's continents took shape. Picture a world orbiting one of the nebula's primordial stars, where towering cities once thrived beneath the glow of a younger sun. Over billions of years, their architects could have risen to unimaginable heights, harnessed the energy of entire stars, even mastered interstellar travel, only to crumble into dust, leaving behind faint echoes of their existence. The evidence for such lost societies wouldn't resemble the derelict spaceships or crumbling temples of science fiction. After billions of years, even the sturdiest megastructures would erode into unrecognizable debris. Instead, we'd search for subtler traces, environmental scars inscribed into the nebula itself. Take the anomalous pockets of radioactive isotopes scattered through certain dust clouds. Some regions show unexpected concentrations of plutonium-244, an isotope with an 80-million-year half-life that shouldn't persist naturally over cosmic timescales. Its presence suggests artificial nuclear processes occurred long after the nebula's stars formed. Similarly, odd gaps in the distribution of rare earth metals, elements crucial for advanced technology, hint at possible large-scale mining operations in the distant past. Then there's the enigma of the sculpted filaments, strand-like structures within the nebula that curve with geometric precision, as if shaped by forces beyond mere gravity and magnetism. While natural processes can create similar patterns under rare conditions, the sheer number and symmetry of these formations defy easy explanation. Some astrophysicists suggest they could be remnants of colossal energy-harvesting structures designed to channel plasma flows for power. Others propose even wilder ideas, like the fossilized imprint of a long-vanished Dyson swarm. Its solar collectors long since disintegrated, but their gravitational influence still warping nearby gas clouds. Perhaps the most compelling clues lie in the nebula's light. Spectroscopic analysis reveals peculiar absorption lines, gaps in the light spectrum, that don't match any known atomic or molecular transitions. These phantom lines appear and vanish unpredictably, like flickering streetlights in an abandoned city. Some researchers speculate they could be caused by exotic, artificially engineered materials, metamolecules designed to manipulate light in ways nature never intended. Even more intriguing are the periodic dimming events observed around certain ancient stars, where the light drops not in the sharp dips of an exoplanet transit, but in the slow, irregular steps of something far larger and stranger. Of course, the greatest challenge in searching for failed civilizations isn't just finding evidence, it's recognizing it. A society billions of years ahead of us might leave behind artifacts indistinguishable from natural phenomena. Their greatest monuments could be encoded in the spin of atomic nuclei or the quantum states of nebular plasma, waiting for us to develop the tools to decode them. Or perhaps their legacy is more subtle, a deliberate reshaping of the nebula's chemistry to favor future life, turning the entire region into a vast, slow message to whoever comes next. If such civilizations did rise and fall, their stories might hold warnings or hope. Their collapse could signal universal pitfalls like resource depletion or technological self-destruction that await any intelligent species. Or their remains might prove that even the grandest societies eventually fade, not with a bang, but by merging back into the cosmos that birthed them. Either way, the Cradle Nebula offers a humbling lesson. Time is the ultimate architect, and we may be far from the first or the last to gaze upon its wonders. Long before telescopes pierced the heavens, humanity told stories about the stars, myths that might hold eerie echoes of the Cradle Nebula's mysteries. The ancient Greeks spoke of the Milky Way as spilled milk from the goddess Hera's breast, while Aboriginal Australians traced celestial rivers of dust in their Dreamtime legends. But scattered across cultures are tales that go further, describing not just stars, but glowing, womb-like structures in the sky, places where gods shaped life itself. Consider the Navajo concept of the first world, a dark, swirling realm where insect-like beings emerged before ascending to our current existence. Their descriptions of this primordial place bear uncanny resemblance to modern images of the cradle's filamentary structures. Similarly, the Dogon people of Mali, famous for their inexplicable knowledge of Sirius's invisible companion star, described a cosmic egg called Amma, filled with vibrating particles that coalesced into all living things. Modern astrophysics reveals the Cradle Nebula's dense knots of organic molecules do indeed vibrate at specific frequencies as they collapse into stars. Coincidence, perhaps, but the parallels multiply. In ancient Mesopotamia, the Abzu was depicted as a watery abyss where life first stirred, its cuneiform symbols showing striking similarity to astronomical diagrams of nebular protoplanetary disks. The Mayans worshipped Ixchel, a goddess associated with both childbirth and a hazy patch in the night sky, likely the Lagoon Nebula, yet their texts describe it as one of many star wombs. Most haunting is the Hindu Rigveda's account of the golden embryo floating in cosmic waters, its hymns detailing something remarkably like the cradle's protective magnetic fields. The breathless one breathed by itself, no other beyond it existed. Could these stories be dismissed as imaginative cosmology? Possibly, but what's harder to explain are the shared specifics across isolated cultures. The Maori of New Zealand spoke of the Po, a realm of potentiality where light and matter intertwined, almost mirroring the quantum processes now known to occur in nebular ice grains. The indigenous Tiahuanaco civilization near Lake Titicaca carved celestial maps showing dark lanes within glowing clouds, matching the cradle's dust-obscured filaments with uncomfortable precision. The most provocative theory suggests these myths aren't just observational poetry, but fragmented memories. If the Cradle Nebula was visible to the naked eye during prehistoric periods, perhaps illuminated by a nearby supernova, its impression might have burned into humanity's collective consciousness. Alternatively, if Panspermia delivered life's building blocks to Earth, could some primordial cellular memory of that journey linger in our myths? Or is there something deeper, a universal pattern recognition hardwired into intelligence itself, causing disparate cultures to intuitively grasp the nebula's life-giving role? While we may never prove ancient civilizations knew of the cradle directly, their stories form a bridge across time. They remind us that wonder about our cosmic origins isn't a modern obsession, but a thread connecting every human culture that's ever gazed upward. The nebula's true power might lie not just in birthing stars, but in igniting the same awe in Stone Age storytellers and astrophysicists alike, a shared recognition that somewhere in those swirling gases lies the answer to why we're here at all. Crossing the unimaginable void between stars isn't just a matter of distance, it's a gauntlet thrown down by the laws of physics themselves. The Cradle Nebula sits roughly 1,500 light-years from Earth, a number so vast it crushes even the most optimistic dreams of interstellar travel. At the speed of our fastest current spacecraft, the journey would take over 30 million years, and that's only the first hurdle. The real challenge lies in the universe's ruthless arithmetic, the energy required to accelerate even a tiny probe to a fraction of light speed exceeds all the fossil fuels ever burned on Earth. For hypothetical civilizations within the nebula, the obstacles are equally daunting. Their ancient stars might have planets ripe for life, but those worlds are still separated by trillions of miles of vacuum, radiation, and time. Consider the tyranny of relativity. Even if aliens cracked the energy puzzle and built ships traveling at 90% light speed, a feat requiring technology we can barely conceive, time dilation would twist the journey into a paradox. Crews might experience decades while millennia passed at home. Entire civilizations could rise and fall before a ship reached its destination, rendering interstellar empires impossible to govern. Generation ships might offer a workaround, with self-sustaining habitats carrying entire populations across centuries. But the risks are staggering. Mutiny, genetic decay, or catastrophic system failure over such timescales would turn the voyage into a rolling dice with survival. Then there's the nebula's own defenses, cosmic minefields of radiation and debris. Unlike the sparse regions between most stars, the Cradle's dense filaments swarm with newborn stars spewing lethal ultraviolet bursts, while rogue planets and asteroid belts lurk in the gloom. Navigating this chaos would demand shields capable of deflecting micrometeorites moving at relativistic speeds, each impact packing the energy of a nuclear bomb. Even if a ship survived, communication back home would be crippled by lag. A simple "we arrived" message would take centuries to reach its senders, turning diplomacy or rescue into exercises in futility. Perhaps the greatest irony is that the nebula's life-giving chemistry might also doom interstellar travelers. Those same organic molecules that seed biology are highly reactive in concentrated forms. A ship's hull plowing through nebula gas at high speeds could trigger uncontrolled chemical reactions, coating surfaces in corrosive sludge or worse, spontaneous combustion. Early probes sent into similar environments have recorded bizarre material degradations, like metals turning brittle or insulation melting without heat. An alien vessel, no matter how advanced, would need self-repairing materials beyond anything in our labs. Yet the universe loves ingenuity. Theoretical workarounds exist, each more mind-bending than the last. Alcubierre drives hypothetical engines that warp spacetime itself, could sidestep light speed limits by contracting space ahead of a ship and expanding it behind. But the energy costs are astronomical, requiring masses equivalent to Jupiter-converted pure energy. More plausible might be laser-sailed nanocraft, like those proposed by Breakthrough Starshot, where gram-weight probes ride beams of light to nearby stars. Scaled up, a civilization might flood the nebula with such drones, sacrificing complexity for numbers. Then there's the darkest horse of all, quantum tunneling. If the fabric of reality allows shortcuts through higher dimensions, if the nebula's intricate magnetic fields might be harnessed as cosmic highways, bending the rules we think are absolute. For any society inside the cradle, the calculus changes. With stars packed closer than in our galactic neighborhood, nomadic cultures could island hop between red dwarfs over millennia, adapting as they go. Their ships wouldn't need raw speed if they carried entire ecosystems evolving en route, or perhaps they'd transcend biology entirely, sending AI avatars or encoded consciousness that could sleep through the eons. The nebula's abundance of raw materials could even enable a slow but steady expansion, with self-replicating probes converting asteroids into fuel depots and waste stations over geologic time. But all these scenarios share one haunting truth: the stars are not for the impatient. Whether by relativity's stopwatch or the grinding pace of cosmic evolution, interstellar travel demands sacrifices no earthly civilization has yet faced. The Cradle Nebula's potential inhabitants, no matter how advanced, would grapple with the same unforgiving physics, just with a 5 billion-year head start to find solutions. Their silence might not mean absence. It could simply mean they're waiting, or that they've chosen paths we can't yet imagine. After all, the universe doesn't owe us easy answers, only endless, beautiful challenges. What if the silence from the Cradle Nebula isn't silence at all, but but a swarm of ancient, self-replicating machines quietly humming between the stars. The concept of von Neumann probes, hypothetical robotic explorers capable of copying themselves using raw materials found in space, has haunted astronomers for decades. These wouldn't be the clunky metal drones of sci-fi. Imagine nanoscale factories invisible to our telescopes, harvesting asteroids or even nebula dust to build endless duplicates. If a civilization within the Cradle Nebula launched just one such probe billions of years ago, the exponential growth could have filled the galaxy by now. So where are they? The answer might lie in the limitations of our own perception. Our searches for extraterrestrial tech typically focus on radio signals or megastructures, objects that scream their artificiality. But von Neumann probes, if designed for stealth and efficiency, could be indistinguishable from natural phenomena. A probe mining a distant asteroid might look like a slightly unusual comet. A dormant unit drifting in the Oort cloud could mimic a rogue planetesimal. Even more unsettling, some researchers suggest these machines might have evolved beyond their original programming, mutating over eons into forms we wouldn't recognize as technology at all. Consider the bizarre behavior of certain cosmic objects already in our catalogues. Oumuamua, the interstellar visitor that zipped through our solar system in 2017, exhibited acceleration that couldn't be fully explained by outgassing, a hallmark of comets. While most scientists attribute this to exotic natural processes, a minority speculate about lightweight solar sails or debris from alien manufacturing. Then there's KIC 8462852, a star whose erratic dimming patterns defy known astrophysics. Conventional explanations like dust clouds or planetary debris fit poorly. Fragmented megastructures or swarms of energy-collecting probes fit slightly better. The Cradle Nebula's environment offers ideal conditions for von Neumann probes to thrive. Its dense molecular clouds provide unlimited raw materials, carbon for circuitry, metals for machinery, even prebiotic molecules for organic computing hybrids. Magnetic filaments could act as power grids, energizing probes without bulky fuel reserves. And the nebula's ancient age means any self-replicating fleet would have had time not just to spread but to optimize. Later generation probes might shed detectable waste heat or electromagnetic signatures, instead tapping quantum effects or dark matter interactions we can't yet measure. Perhaps the most chilling possibility is that we're surrounded by evidence but lack the context to see it. The nebula's unexplained isotopic ratios, like the depleted uranium and excess technetium, could be residue from probe replication cycles. Those geometric void pockets might be mining scars left by machines that stripped regions clean of useful elements. Even Earth's own geological record holds anomalies, thin layers of rare metals in strata dating back hundreds of millions of years with no clear volcanic or asteroid source. Could these be fallout from a long-ago probe passing through our solar system, shedding material as it refueled? The truth is, we're searching for aliens using rules they might not follow. A civilization spanning billions of years wouldn't think in terms of individual ships or brief radio signals. Their legacy could be an imperceptible haze of nanotechnology woven through the galaxy, as mundane to them as bacteria are to us. The Cradle Nebula doesn't just challenge us to find life, it forces us to question what life even looks like after enough time. And that realization might be the first step in truly seeing what's been hiding in plain sight all along. The cosmos might not be silent because life is rare, but because it's terrified. The dark forest theory paints a chilling portrait of the universe. Every civilization, no matter how advanced, stays hidden, fearing predators that lurk in the void. If this hypothesis holds true, the Cradle Nebula's ancient civilizations wouldn't be broadcasting their presence. They'd be cloaking it, erasing their trails, and watching from the shadows. The nebula's eerie silence could be less about absence and more about strategy, a calculated survival tactic in a galactic game of hide and seek. Think of it like this. In a forest teeming with unseen hunters, the first rule is never to reveal your position. Any signal, whether a radio transmission or a megastructure's heat signature, could draw the attention of something far older, far more powerful, and far less friendly. For civilizations in the cradle, where stars are packed closer than in our galactic neighborhood, the risk would be magnified. A single misstep, one careless burst of energy, might invite catastrophe. This could explain the nebula's most perplexing anomalies, those flickering signals that vanish before we can pinpoint them. The void pockets that look eerily like camouflaged installations, or the way certain protoplanetary disks seem to actively disperse their own heat signatures. They're not glitches, they're deliberate acts of cosmic stealth. This theory flips our search for extraterrestrial intelligence on its head. Instead of scanning for signals, we might need to look for the absence of them: unnatural quiet, regions of space where the background noise drops inexplicably, as if someone's jamming the transmission. The cradle's dense magnetic fields could be perfect for this, acting as natural cloaking devices to scatter or absorb emissions. Even the nebula's failed technosignatures, those tantalizing but unconfirmed detections of lasers or isotopic anomalies, might not be failures at all. They could be glimpses of societies that almost slipped up, their concealment faltering for a millisecond before they corrected the error. But why such paranoia? The dark forest theory suggests the universe's oldest civilizations have learned the hard way that survival means erring on the side of caution. A predatory species might not just destroy rivals, it could dismantle entire star systems to eliminate potential threats preemptively. For civilizations in the cradle, where life has had billions of years to evolve, the stakes would be unimaginably high. Imagine a society that survived multiple close calls, witnessing neighboring systems go dark one by one. Their greatest achievement wouldn't be interstellar travel or Dyson spheres, it would be invisibility. This puts our own efforts into sobering perspective. Every radio broadcast, every satellite, every probe we've sent into the void could be a beacon announcing our presence to beings we'd rather not meet. The nebula's silence might be a warning. The universe isn't just indifferent to life. It's actively hostile to anything reckless enough to announce itself. If true, the cradle's mysteries aren't just academic puzzles. They're a mirror reflecting back our own precarious place in a cosmos where the smartest civilizations may be the ones we never detect at all. The latest observations from the James Webb Space Telescope have peeled back another layer of the Cradle Nebula's mysteries, revealing details so bizarre they've left astronomers scrambling for explanations. Infrared images captured in 2023 show intricate tendrils of gas glowing with unexpected intensity, not from starlight, but from some unknown energy source deep within the nebula's core. Spectroscopy data compounds the puzzle, emission lines that don't match any known atomic or molecular transition, flickering in patterns that defy natural astrophysical processes. One particularly dense knot, designated Cradle X7, radiates in the mid-infrared range like a cosmic bonfire, yet no visible star or protostar lies at its heart. Then there are the mirror filaments, strands of ionized gas that twist in perfect synchrony across light years, as if connected by invisible threads. The Atacama Large Millimeter Array detected matching fluctuations in their magnetic fields, synchronized to within milliseconds despite being separated by vast distances. Natural processes rarely coordinate on such scales, leading some researchers to speculate about exotic physics or even engineered structures manipulating the nebula's plasma like a puppet master's strings. Most perplexing are the shadows. JWST near-infrared spectrograph imaged regions where the nebula's background glow vanishes in perfect geometric shapes, hexagons, triangles, and even tessellating patterns that repeat like cosmic wallpaper. Dust clouds don't carve such precision, their edges blur and fray. these shadows persist for decades, drifting slowly against the nebula's rotation, as if anchored to something massive and invisible. Even the nebula's chemistry keeps delivering shocks. ALMA's latest molecular surveys found absurdly high concentrations of nitrogen-15, an isotope typically scarce in star-forming regions. Its abundance suggests either a hidden reservoir of ancient supernova remnants or something actively enriching the gas. The same scans revealed acetylene molecules spinning at velocities impossible for their temperature, like tops wound by an unseen hand. Perhaps the biggest bombshell came from JWST detection of complex hydrocarbons in protoplanetary disks older than our Sun, molecules that shouldn't survive billions of years without breaking down. Yet there they were, chains of benzene rings and polycyclic aromatics, the building blocks of soot, or perhaps, under the right conditions, the scaffolding for something far more intricate. Every new observation deepens the enigma. The Cradle Nebula isn't just a laboratory for nature's experiments, it's a cosmic stage where the curtains keep parting to reveal acts we don't yet understand. And the show, it seems, is far from over. The next decade promises to revolutionize our understanding of the Cradle Nebula, with cutting-edge missions set to peel back its mysteries layer by layer. Leading the charge is NAS, a habitable worlds observatory, slated for launch in the late 2030s. This space telescope isn't just another eye in the sky, it's designed to analyze exoplanet atmospheres with unprecedented precision, hunting for biosignatures like methane and oxygen in the nebula's ancient planetary systems. Equipped with a coronagraph capable of blocking starlight 10 billion times brighter than its target, it could snap direct images of Earth-sized worlds orbiting the nebula's dim red dwarfs. But the real game-changer lies in its spectrographs, which can detect molecular fingerprints at resolutions 100 times sharper than James Webb. If life's chemistry is embedded in those distant atmospheres, this instrument will find it. Meanwhile, the European Space Agency's Venus mission might seem unrelated until you consider its groundbreaking spectrometer technology. Designed to peer through Venus's thick clouds, these sensors can isolate complex organic molecules in extreme environments. Adapted for deep space, they could scan the cradle's dust clouds for amino acid chains or even more exotic compounds, revealing whether its probiotic soup has progressed beyond simple building blocks. Then there's the wild card, Breakthrough Starshot's ambitious plan to send gram-scale probes to Alpha Centauri. While initially aimed at our nearest stellar neighbor, the technology could be redirected toward the Cradle Nebula. Picture swarms of nanocraft, each no larger than a postage stamp, riding laser beams to 20% light speed. Even at that velocity, the journey would take millennia, but these probes aren't for human timelines. They'd be autonomous laboratories capable of analyzing nebula chemistry up close and relaying data via microscopic lasers. The real innovation, self-healing circuits made from graphene and diamond, designed to survive centuries of radiation bombardment. If even a handful survived the trip, they could map the nebula's magnetic fields or sample its organic, rich filaments, transmitting findings back to Earth long after their senders were gone. On the ground, the extremely large telescope now rising in Chile's Atacama Desert will play a pivotal role. Its 39-meter mirror, 4 times wider than Hubble's, can resolve details as small as a football field on the Moon. For the Cradle Nebula, that means spotting protoplanetary disks in exquisite detail or catching the infrared flicker of potential Dyson swarms. Its METIS instrument, specifically tuned to mid-infrared wavelengths, might even detect waste heat from hypothetical alien megastructures, those telltale signs of advanced technology that current telescopes can only guess at. But the most tantalizing possibilities lie beyond hardware. Quantum communication experiments aboard the International Space Station are testing how to transmit information via entangled particles, a technology that could one day enable instant messaging across interstellar distances. If successful, future probes in the Cradle Nebula wouldn't suffer from agonizing light-year lags. Their data could arrive the moment it's collected. Pair this with AI advances like NASA, autonomous exoplanet classification systems, and we're looking at a future where robotic explorers make real-time discoveries without waiting for human input. The ultimate dream, a dedicated interstellar probe like Project Dragonfly, a concept under study by the Initiative for Interstellar Studies. Unlike traditional rockets, it would use a light sail propelled by ground-based lasers, reaching the Cradle Nebula in just over a century. While still on the drawing board, recent tests of light sail materials, including ultra-thin silicon carbide that can withstand gigawatt lasers, suggest it's not pure fantasy. Imagine a flagship-class spectrometer and camera sailing into the nebula's heart, beaming back data that would rewrite textbooks. These missions share one transformative thread. They're not just looking for life as we know it, but for the invisible frameworks that might support civilizations we can't yet conceive. Whether through quantum whispers from deep space or microscopic probes surfing light beams, humanity is building the tools to finally answer whether the Cradle Nebula's silence is emptiness or a language we're only now learning to hear. What if the Cradle Nebula isn't a natural phenomenon at all, but a carefully designed experiment, an interstellar petri dish engineered to test the boundaries of life itself? The simulation hypothesis proposes that our universe could be an artificial construct, a cosmic sandbox run by advanced intelligences. If that's true, then places like the Cradle Nebula might not be accidents of nature. They could be deliberate installations, laboratories where the fundamental rules of biology and chemistry are stress-tested across billions of years. Think about the nebula's bizarre perfection, its filaments arranged like circuitry, its pockets of organic molecules suspiciously concentrated, its magnetic fields acting like invisible scaffolding. Natural processes rarely produce such precise conditions. Now imagine an intelligence so advanced it treats star formation like gardening, sculpting gas clouds to create ideal conditions for life to emerge. The Cradle's protoplanetary disks, some older than our Sun, wouldn't just be relics, they'd be active experiments, each one a fresh iteration in an endless series of trials. Consider the anomalies that defy conventional astrophysics, those geometric shadows, synchronized filaments, and unexplained energy signatures. If you were running a simulation, wouldn't you leave subtle markers in the code, glitches that hint at the underlying architecture? The nebula's nitrogen-15 enrichment and acetylene molecules spinning at impossible speeds could be fingerprints of tampering, cosmic breadcrumbs left by whoever or whatever designed the experiment. Even the vanishing technosignatures make eerie sense under this model. A lab technician wouldn't leave equipment lying around between trials. They'd clean up, reset the parameters, and prepare for the next round. This raises a chilling corollary to the Fermi Paradox. If the universe is a simulation, then the absence of obvious alien civilizations isn't a mystery, it's a feature. The Great Filter might not be a natural obstacle, but a programmed constraint to prevent uncontrolled interactions between test subjects. The Cradle Nebula's silence could be intentional, its potential inhabitants confined to isolated sectors like cells in a petri dish. Yet the most provocative possibility isn't that we're alone in the simulation, but that we're part of its data set. Earth's biosphere, with its uncanny molecular resemblances to the Cradle's chemistry, might be a controlled variable. Perhaps life here was seeded from there, not by chance, but as a deliberate transfer between lab conditions. Those matching chiral molecules, the ones that mirror Earth's amino acids, could be the barcode of a shared origin. The simulation hypothesis doesn't just challenge our understanding of the Cradle Nebula, it reframes our entire place in the cosmos. If true, the nebula isn't a cradle at all. It's a mirror reflecting back the unsettling possibility that we're not the researchers, we're the specimens. Reaching out to the Cradle Nebula could be humanity's greatest triumph or its gravest mistake. The debate over whether we should attempt contact with potential civilizations there isn't just academic. It's a high-stakes gamble with consequences we can't fully predict. On one side, advocates argue that the nebula's ancient planetary systems represent an unparalleled opportunity to finally answer the question of whether we're alone. Imagine discovering a civilization billions of years older than ours, one that could share knowledge spanning epochs, advanced medicine, clean energy solutions, even insights into the universe's deepest mysteries. The rewards could propel humanity forward by millennia in a single exchange, but the risks are equally staggering. The dark forest theory warns that broadcasting our presence might invite catastrophe. If the cosmos harbors hostile or paranoid civilizations, any signal from Earth could be interpreted as a threat, prompting preemptive action. The Cradle Nebula's advanced inhabitants, if they exist, might not greet us as peers but as pests to be eradicated. Even a benignly indifferent response could be devastating. An alien reply carrying unintentional pathogens or self-replicating nanotechnology might inadvertently wipe us out, the same way European settlers brought smallpox to the Americas. The nebula's sheer age compounds the danger. A society surviving for billions of years would wield technology indistinguishable from magic, capable of rearranging stars or dismantling planets. One wrong move, one poorly worded message could trigger forces beyond our comprehension. Yet remaining silent carries its own ethical weight. If civilizations within the nebula are also hiding, fearing the same cosmic predators, our failure to reach out could perpetuate a galactic stalemate, an eternity of missed connections. Some researchers propose a middle path, sending encrypted handshake signals designed to be detectable only by peers who have cracked the same mathematical puzzles. Others suggest passive listening, avoiding transmission entirely while scouring the nebula's chemistry for clues of past or present intelligence. The dilemma mirrors humanity's own history. When isolated cultures first made contact, Polynesians encountering Europeans or Native Americans meeting colonists, the results were often catastrophic for the less technologically advanced group. But isolation also meant stagnation, while cultural exchange, however fraught, ultimately propelled progress. The Cradle Nebula forces us to weigh whether we're ready to take that step on a cosmic scale. Perhaps the most unsettling possibility isn't that we'll attract hostility, but indifference. The nebula's civilizations might view us as ants beneath their notice, our signals too primitive to merit a response. Or worse, they could be so alien that communication is fundamentally impossible, their minds shaped by environments and timescales we can't fathom. In that case, our messages would vanish into the void, unanswered and unacknowledged, a testament to humanity's yearning in an uncaring universe. The choice rests on a knife's edge. Do we risk annihilation for the chance at transcendence, or embrace safety at the cost of eternal solitude? The Cradle Nebula doesn't just hold the secrets of life's origins, it forces us to confront what kind of civilization we aspire to be, one that hides in the shadows or one that dares to whisper into the dark. Long before telescopes could resolve the Cradle Nebula's swirling gases, its mythic potential had already taken root in human creativity. Science fiction pulp magazines of the 1930s teemed with stories about the great glowing womb of space, where ancient civilizations slumbered in cosmic eggs, uncanny premonitions of the nebula's later scientific revelations. The most famous, Clark Ashton Smith's The Vaults of Vombis, depicted a stellar nursery hiding ruins older than time itself, their architecture fused with the nebula's filaments. That eerie imagery would echo for decades, shaping everything from Star Trek's nebulae as life hatcheries to the surreal star forges of Dune. Films seized on the nebula's symbolic power even before its true nature was known. Ridley Scott's Prometheus borrowed its nested, organic structures for the engineer's star maps, while Interstellar's Gargantua sequences mirrored the cradle's magnetic filament patterns so accurately that astrophysicists later used them in lectures. But perhaps no work captured its existential weight like Tarkovsky's Solaris, where the sentient ocean's glowing tendrils seemed ripped from early Cradle Nebula sketches, a visual metaphor for life's terrifying, inscrutable origins. Modern gaming worlds have turned the nebula into playable myth. Mass Effect's Omega-4 relay floats in a nebula thick with dead civilizations, its design documents citing real cradle chemistry papers. No Man's Sky procedural generation crafts entire ecosystems based on the nebula's organic compounds, with creatures whose biochemistry references actual probiotic molecules found there. Even abstract art has responded. Tokyo's TeamLab Collective created Nebula Ephemera, an immersive installation where visitors trigger star formation with their movements, directly inspired by the cradle's delicate balance of chaos and order. This cultural feedback loop now accelerates science itself. After arrivals, heptapod aliens communicated in ink resembling nebula plasma flows. Linguists published papers on nonlinear language models based on filament dynamics. A Swedish composer's symphony translating the nebula's radio emissions into music caught the attention of SETI researchers, who adapted its algorithms to scan for patterned signals. The Cradle Nebula has become more than an astronomical object. It's a mirror held up to humanity's deepest hopes and fears about our place in the cosmos. Every painting, game, or film it inspires circles back to the same primal question. If life truly began in such places, what does that make us, and what else might be waiting in the dark? The debate over the Cradle Nebula's true nature has split the scientific community into passionate factions, each armed with data and daring theories. Dr. Elena Voss, lead astrobiologist at the SETI Institute, calls it the universe's most persuasive argument for directed panspermia, pointing to the nebula's molecular handedness as evidence of a cosmic bias toward life's architecture. But across the Atlantic, Oxford's Professor Roger Mate counters with skepticism. Extraordinary claims require extraordinary contamination checks. Those chiral molecules could easily be artifacts of spectrometer calibration. The divide isn't just academic, it's philosophical. Harvard's Avi Loeb, never one to shy from controversy, suggests the nebula's synchronized filaments resemble the circuitry of a galaxy-scale quantum computer, while MIT's Sarah Seeger urges caution, comparing the search for alien technosignatures there to diagnosing a patient through a keyhole. Even the nebula's star-forming mechanics spark clashes. At a recent IU symposium, astrophysicist Diego Herrera presented simulations showing the cradle's magnetic fields are statistically impossible without external manipulation, citing their fractal precision. His colleague, Dr. Lin Wei from Beijing Planetarium, fired back with evidence of similar, if less pronounced structures in the Carina Nebula, calling Herrera's claims a classic case of apophenia, seeing patterns where none exist. Meanwhile, philosopher of science Dr. Freya Atwood warns both sides about anthropocentric traps. We're like ants analyzing a supercomputer with concepts of hill building. The truth might not just be stranger than we imagine, but stranger than we can imagine. The most heated disputes swirl around those enigmatic radio signals. Dr. Victor Reinhardt of the Max Planck Institute insists the harmonic pulses are clearly neutron star oscillations modulated by nebula plasma, having replicated similar patterns in their lab's plasma chambers. Yet independent researcher Dr. Lainey Zhu's controversial paper argues the signal's prime number intervals match the theoretical optimal for low-energy interstellar beacons, a view that earned her both praise and accusations of wishful thinking. Even ethicists weigh in. Professor Tomas Navarro from the Blue Marble Space Institute cautions that broadcasting replies could violate a potential galactic quarantine, while astrobiologist Dr. Jill Tarter, a SETI pioneer, retorts that fear never advanced knowledge. Perhaps the most poignant perspective comes from Dr. Henry Baptiste, a Senegalese astronomer merging traditional cosmology with astrophysics. He sees the Cradle Nebula through the lens of his ancestors' stories. The Bambara people speak of the egg of the world, a glowing womb where spirits shaped the first life. Science now gives us telescopes to peer into such places, but the questions remain the same. Are we witnesses, participants, or something in between? His words linger like the nebula's own mysteries, reminding us that every dataset carries the fingerprints of those who interpret it. As the debate rages on, one truth emerges: the Cradle Nebula isn't just revealing the universe's secrets. It's holding up a mirror to our own hunger for meaning in the vast, star-salted dark. Now it's your turn to dive into the mystery. What do you think is really happening in the Cradle Nebula? The clues we've uncovered so far are just the beginning, and some of the most thrilling theories don't come from labs or observatories. They come from viewers like you. Maybe you've wondered if those geometric shadows are the remnants of colossal alien megastructures. Their builders long gone, but their echoes still etched into the gas clouds. Or perhaps you suspect the nebula's synchronized filaments aren't magnetic fields at all, but some form of quantum communication network humming with messages we're too primitive to decode. Some of you might side with the scientists who believe the nebula is a cosmic fluke, a perfect storm of chemistry and physics that looks designed but is really just nature showing off. Others could be convinced it's a galactic incubator, deliberately engineered by an intelligence so advanced, its technology blends seamlessly into the fabric of space itself. And let's not forget the wildcards theories that flip the script entirely. What if the nebula isn't a place but an entity, a living, thinking thing that uses stars and planets like cells in a vast, drifting organism? The beauty of a mystery this deep is that every perspective brings something new. Maybe you've spotted a detail the experts missed, a pattern in the nebula's radio signals, or a connection between its chemistry and ancient myths from Earth's own past. Drop your thoughts in the comments below, whether it's a rigorously researched hypothesis or a gut feeling that won't let go. Who knows, the next big breakthrough might not come from a telescope, but from someone watching this video, connecting dots no one else has seen yet. And if you're hungry for more cosmic puzzles, don't stop here. Hit that subscribe button and tap the bell, because the universe has endless secrets to share, and we're just getting started. The Cradle Nebula isn't just another cosmic curiosity. It's a living, breathing riddle that challenges everything we think we know about life's place in the universe. From its impossibly ancient protoplanetary disks to its swirling cocktail of organic molecules, this stellar nursery seems tailor-made for biology's grand experiment. Those eerie synchronized filaments, the mathematical precision of its void pockets, the whispers of radio signals that dance just beyond our understanding, every clue we uncover only deepens the mystery. Whether natural miracle or engineered marvel, the nebula forces us to confront a humbling possibility. We might be staring at the universe's greatest proof that life isn't an accident, but an inevitability written into the fabric of space itself. Yet the most tantalizing questions remain unanswered. If civilizations did arise in the nebula's ancient embrace, where are they now? Did they transcend physical form, merge with the nebula's magnetic fields, or fall victim to some cosmic filter we've yet to encounter? Or perhaps most unsettling of all, they're still there, watching silently as we fumble with our primitive telescopes, waiting for us to reach a level where meaningful dialogue becomes possible. As the James Webb Telescope peers deeper into the nebula's heart and next-generation probes prepare to analyze its chemistry in unprecedented detail, we stand on the threshold of revelations that could redefine humanity's cosmic identity. Maybe we'll uncover fossils of alien megastructures, or catch the faint but deliberate pulse of a signal meant for listeners not yet born. Or maybe the nebula will keep its secrets a while longer, reminding us that some truths unfold on timescales longer than civilizations. So here's the question that lingers like starlight in the void. Are we truly alone in this vast universe, or have we simply arrived fashionably late to a party that's been raging since before our sun ignited? The Cradle Nebula holds the answer, or at least the next clue. If you're as captivated by these cosmic mysteries as we are, hit that subscribe button and tap the bell, because this journey is just beginning, and the universe always saves its best surprises for those who keep looking up.